We are going live in 3, 2, 1. Please start, sir. We are live.
Hello, good evening, everyone. It's a great pleasure to welcome you all, and it's nice to see a galaxy of experts for ovarian cancer today. Until recently, our knowledge of a genetic contribution to ovarian cancer focused almost exclusively on mutations in the BRCA1 and 2 genes. However, now there is an understanding of the larger phenomena of homologous recombinant deficiency, HRD, a biomarker that plays a critical role in treatment decisions for patients with cancer. Definition of HRD are heterogeneous and varies widely among the scientific and medical communities. So various terms have been used in the literature to describe HRD, including BRCA-NES, BRCA-like, and genomic scarring. Today, we have with us Dr. Professor Robert Coleman from Texas Oncology, who will help to clinically understand how to optimally use this complex biomarker to identify patients who would benefit from targeted therapy. Although everyone knows Professor Coleman, but just a customary, Professor Coleman completed his Ops and Gynecology residency at Northwestern University Medical Center in Chicago, Illinois, and completed his fellowship at the University of Texas MD Anderson Cancer Center in 1993. Prior to joining the MD Anderson faculty in 2004, he served as Vice Chairman, Department of Obstetrics and Gynecology at the University of Texas Southwestern Medical Center in Dallas. So good evening, everyone, once again, and good evening to you, sir. It's a pleasure to have you with us for this meeting. We look forward, for your interaction and the first topic. So Bhavna, anything from your side, or we invite Professor Coleman for his talk?
Yes, Dr. Coleman can start, please.
So Professor Coleman, over to you, sir. You're going to give a complete insight on the clinical utility of HRD testing and ovarian cancer. Over to you, sir.
Thank you. Thank you. It's so good to be with you. Let me share my screen here. Yep, there we go. Somebody can give me the power here. Let's see if I can get it. Okay, you can't see it. Let's see if you can see it now. Let me know if you can see it. I got multiple screens here. Are you able to see that?
Yes, sir.
Okay.
Just you need to do the full screen mode.
Oh, I got it at full screen. Oh, maybe you're, hold on here. Are you, which modality you're seeing? Because I have full screen on mine. You see full screen?
Yes, sir.
Okay, good. Sorry about that. All right, great. Well, welcome everyone. It's great to be with you tonight. This is a great opportunity to talk about this topic that is so important to us all, who care for these ovarian cancer patients. The way that I've got this structured, we're gonna do a little bit of background. Based on the survey that some of you completed, it sounds like your knowledge of this space is pretty good. So I'll be able to kind of quickly go through that, and then I'm going to walk through the NCCN guidelines that really have governed how we practice in the United States. And again, it is a reflection of the FDA approvals of these drugs in the frontline setting for ovarian cancer patients. And so it may be a little different than what's available to you, but I think you'll see the mindset or how the rationale works for that. And then we'll stop and we'll go through, there'll be a presentation on the HRD assay, and then I'll go through kind of some common clinical questions that come up and then walk through a case. So hopefully we'll be able to get through this in the next 90 minutes or so, and happy to take your questions. I think you can put questions in the chat if you want, and I'll try to monitor that as we go through this as well. So these are my disclosures. So I like to start with this slide because in the United States, it's been very interesting to see that the incidence rate of ovarian cancer is actually declining, and with it, almost to a parallel degree, is the reduction in mortality. So it's pretty interesting when you think about it, because at least in the United States, across most of the cancers that are reported to the cancer database, has seen a decline of about 2% over the last 5 years. The one very much outlier is endometrial cancer. So we're actually seeing that increase. It's the #1 increasing tumor in women. So it's becoming a bigger burden. But what these slides do not capture very well is the clinical burden that we all deal with every day. That particular statistic is measured in the number of women that actually have ovarian cancer at any one time. So while these numbers represent new cases per year and deaths per year, which seem to be very steady, the number of women who actually have this disease at any one time is actually increasing. So if you think about that, how can you have less patients diagnosed, but more patients with cancer? And then really the only way that that can happen is by increasing the survivorship of patients with ovarian cancer. And in this kind of slide of natural history, that survivorship is actually happening on both sides of the initial progression. So what we used to say for patients who are newly diagnosed, that the progression-free survival was about a year. And then once the patients progressed, it was about a year until they became in stage became onto supportive care. So that the overall anticipated survival for the average patient was about 2 to 3 years. But what's happened is that we've developed these novel strategies in terms of chemotherapy and maintenance as a partnership. And that has led to an improvement in progression-free survival on the average to about 2.5 years, which is our expectation for these patients in the frontline setting. It's even much longer when we talk about using drugs like PARP inhibitors and anti-VEGF-based therapies that have actually demonstrated even in annotated populations, genomically annotated populations, that this can actually be substantially longer than this 2.5 year interval. And then once patients progress, the number of new therapies that are entering into our clinical domain and continue to expand this clinical domain, not only as treatment, but as treatment and maintenance strategies, is also increasing this post-progression survivorship. So now what used to be a 2 to 2.5 year process was now around 5 years. And indeed, the median overall survival in the United States now is right at 5 years. The median is at 5 years. So it's been very impressive. And again, where PARP has played a role in this story is actually pretty interesting. Because if I go back to that slide here just for a quick second, what you'll notice is that right here, right between in 2014, we saw this big pivot up and it's continued to rise. So how did we get there? Well, we got there because we started using the PARP inhibitors as part of the first approval as a treatment in the 3rd and 4th line in BRCA patients. And then we moved that into earlier lines of therapy with rucaparib. Then we added it as a maintenance strategy following platinum induction in recurrent platinum sensitive patients. And then we moved it into the front line. And that became, kind of the story. So we focus a lot on DNA damage because that's how chemotherapy works, right? We give platinum because it causes adducts. We use paclitaxel because it impairs the mitotic spindle, and so that there's disruption during cell division. So we focus a lot on these repair mechanisms because they provide the differential between a normal cell survival and a cancer cell survival. And so if you can see here that the two of the most important aspects as it relates to PARP inhibitors has been the role that PARP plays in single strand based repair and the role that homologous recombination plays in double strand breaks. And I'll walk through the kind of the cartoon that you probably have all seen. That PARP is an enzyme, a protein that's responsible for recruitment of nucleotides that essentially can fit a template. So you remember that the nucleotides are A, T, G, C. So there's only 4. And so if you know what the template is of the missing DNA material, you can fix this defect fairly easily. But if we block this through pharmacological means or trap it on the DNA, what it leads to is a higher probability under replicative stress of a double strand break. Now, for normal cells, a double strand break can be healed with high fidelity, a process that we call homologous recombination. Now, it's not the only process. So as you can see here, one of the processes by which DNA can repair itself is to just stick the ends together. So there is a process called non-homologous enjoining, which would essentially, or alternate enjoining, which would essentially just stick these processes together. But you can tell that if the read going downstream of DNA happens at, from an early point in time, all of the subsequent reads going to be abnormal. So to protect that from happening, the cell will trim back these edges to provide a leading section that can invade the sister chromatid. So remember, we all have 2 copies of all of our genes. And with invasion of the sister chromatid, there can be a read from that alternate strand. So you see the strand invasion, and you can see it's this particular strand of DNA is getting information from the missing allele in the where the double strand break happened. Once that happens, then there can be this junction resolution by repairing the known template read. And so with that, you get cell survival. So normal cells and cells that are cancerous that have this process intact can essentially fix a double strand break. Okay, and that's one of the issues that we've run into with PARP resistance. But ultimately, cancer cells that have homologous recombination deficiency can't survive this. This doesn't get repaired with high fidelity, and ultimately you get cell kill. So it's really important to understand that PARP inhibition is not like a targeted therapy. Like, it's not focused on the cancer cell specifically because there's a PARP receptor. This is actually creating the opportunity for the differential cytotoxicity to happen because the cancer cell is deficient, and we're taking advantage of that. Now, we've been able to show this quite actively for years. Obviously, we have clinical proof of it, but the story started here just 2005 with these 2 papers published in Nature by Bryant and Farmer. And basically what these 2 studies did is they took cells that had homozygous deletion of BRCA and demonstrated that in the presence of a PARP inhibitor, that those cell lines were exquisitely sensitive to that therapy. So in this particular scenario, the construct for the cancer was artificially manipulated to either provide intact BRCA, either 1 or 2 strands, or deficient. And in the presence of a PARP inhibitor, these cells, which normally would have survived, had died. And so that provided the differential we needed. Now, we pay attention to this in ovarian cancer because BRCA1 and BRCA2 are mutated either in the germline or in the tumor tissue itself in about 25% of our patients. And although that number varies all over the world, this is a pretty consistent frequency that we want to take advantage of. And all of you in that survey, basically understood that this was a highly important and relevant to clinical care because now we have PARP inhibitors that can take advantage of it. Now, in addition to those BRCA mutations, there are a number of proteins that are responsible for this process. And you can see over here, I've got them all there. These are all highlighted, but mutations in some of these genes or methylation or dysfunction of some of these genes can lead to an impaired state of homologous recombination. It may not completely block it out, but it can lead to its inefficiency. And we can take advantage of that, again, using a PARP inhibitor, because the PARP inhibitor is creating the need for the cell to try to fix itself under a double strand break. So that process of vulnerability is called homologous recombination deficiency. And we don't have reliable functional assays right now for identifying homologous recombination deficiency, but we can have evidence that the homologous recombination deficiency is present in the cell by looking at genome-wide alterations. And this is just to give a graphic of what happens in a tumor that has a mutation in BRCA, that when we look for features of heterozygosity, which we would expect to be consistent throughout the genome, we see loss of heterozygosity in multiple areas across the genome. And so this loss of heterozygosity is a decent, not a perfect, but a decent biomarker of homologous recombination proficiency or deficiency. And so we know that there are tumors that are wild type for BRCA, but have similar degrees of loss of heterozygosity. And we call that the BRCA-like situation. And again, it's something we can measure, and it's something we can differentiate from cells that have low levels of loss of heterozygosity. Now, the testing, that first got in the market, there's 3, that are working their way through the approval process, but 2 that have formal FDA companion diagnostic approval have come by these companies. And I just want to share an example as to how we need to understand how to interpret HRD testing. So what you see over here, and this is the Myriad product, but if you look over here, you'll see in these kind of light green bars that this is the loss of heterozygosity score in tumors that are deficient in BRCA. So you can see that in the tumors that have a BRCA mutation, that there is this kind of shift over to relatively high scoring for genomic instability. Now, the major driver of this is the loss of heterozygosity signal that I just mentioned in the last slide. But you'll see here in these darker green graphic here, these are BRCA wild type tumors. And you can see that for the majority of the BRCA wild type tumors, the loss of heterozygosity scores are below this kind of cut point that they've put in this red dotted line. It doesn't eliminate them. You can see that, that there are some of these light green, these are mutated tumors that have low levels of loss of heterozygosity. And you can see there are these BRCA wild type tumors that have high degree of loss of heterozygosity. These are the ones that we're looking for that are BRCA-like, but do not have a mutation in BRCA. And so that's what you get when you provide this test. You get an interpretation of HRD status, and now we have required them to also give us the score, because you can imagine that a score of 41 is going to be very similar in efficacy as a score of 42, even though one would be considered positive and one would be considered negative. So there are false negatives and false positives. And this is further exemplified, by this beautiful study that we don't hear much about, but this was actually presented by Charlie Gorley a couple years ago at ESMO, where they looked at the SOLO-1 data, which we'll go through, and I know you know the data well, that showed that olaparib as a single agent was very active in patients with BRCA mutation. But what Charlie did is he actually looked at the loss of heterozygosity score in that study to see how well those patients who had a BRCA mutation, but a low score of LOH. Remember, in this last slide, these would be these tumors, these light green tumors down here that have a low level of loss of heterozygosity, but are still BRCA mutated. And what you see here is these dotted lines basically show is the same hazard ratio as the ones that had a BRCA mutation and high levels of loss of heterozygosity. So if you wanted to, the take-home message here is that LOH scoring or HRD testing is a decent but an imperfect measure of homologous recombination proficiency or deficiency. Okay, BRCA will always trump it, but in the absence of BRCA, it seems to be a decent biomarker, and we've used it obviously. Now there's been 5, and I'll say there's been 6 because the Athena trial has a press release with rucaparib, and I didn't put it in here yet because we haven't seen the data. But there are now these 6 trials that have essentially been conducted, and I have them all listed here with all of their kind of nuances, and I'm happy to distribute these slides to y'all if you want them. But they vary on many. They have a lot of similarities and some differences. So 4 of these trials are PARP versus placebo. The 4th one being the Athena trial. So you can see that niraparib and olaparib have been compared in various different populations, BRCA mutated, non-BRCA mutated ITT populations against placebo. Then there are these other trials, olaparib PALA-1, which is looking at the addition of olaparib to bevacizumab as a maintenance strategy, and Velia, which I won't talk about, was looking at chemotherapy added, PARP inhibitor veliparib added to chemotherapy, followed by a maintenance strategy. So lots of nuances in these trials, and we can talk about them for lots of discussions, how the assessments were made and all that. But the bottom line is, across all of these studies, is that PARP works. And it works best in the annotated population and least in the biomarker negative population, and HRD is somewhere in between. So let's talk about these studies quickly because I know you know them. SOLO-1 was in newly diagnosed BRCA mutated ovarian cancer. It included both those patients that had a germline mutation in BRCA1 or 2, and those patients who had a somatic BRCA wild type, BRCA germline wild type, but somatic mutation in BRCA, randomized to olaparib versus placebo in a 2-to-1 randomization. And the primary endpoint was investigator-assessed progression-free survival. Now, these patients if they had measurable disease after their surgery, they had to demonstrate a response to treatment at the time. They did not have to demonstrate complete resolution. So there are patients on this study with a BRCA mutated tumor who did not have a complete remission before they went on study. So it's important to understand that. And then they were treated for 2 years if no evidence of disease or intolerance. And of course, these are the data that were presented at ESMO that year in 2018. It was, a very phenomenal report with a huge difference. This hazard ratio of 0.3 represents a 70% reduction in the hazard for progression or death at every point in time of exposure. So for those of you who understand this, how the statistics work with the hazard ratio, the hazard is the average of the risk reduction that occurs at every point in time of exposure. So when you sit in front of a patient and you don't know how well they're going to do, all you can offer that patient is that the reduction in her chances for risk of recurrence or death will be this metric here, which would be a 70% reduction. And so that applies at every point in time as you treat that patient going forward. These data were updated by Susanna Banerjee in the Lancet publication last year. That basically shows a very consistent treatment effect with much longer follow-up. Again, the hazard ratio of 0.33 representing this 70% reduction. And what's really interesting about these curves to me is that you can see out here at 5 years, we're still seeing more than 50% of our patients alive. And the hope is that because the events are so flat here, the events are so limited, that these patients may actually represent cures. So we may be actually changing the cure rate of ovarian cancer BRCA mutated tumors. Very exciting. Now, because there is this association with bevacizumab and the high risk and low risk, which I disagree with, I'll just say it right now, I disagree with that contention. But we have looked at this across all of our studies to see if we could identify if there was a differential effect in patients with higher or with lower or higher prognostic variables for long-term outcome. And you can see that didn't matter. In both of these cohorts of patients, they did well. Now, PRIMA was a study that was designed to kind of catch up because Solo 1 was already out there and moving along. So PRIMA was designed for patients who had bulky disease, essentially poor prognostic cohorts, higher rates of neoadjuvant chemotherapy, and higher numbers of patients who actually ended chemotherapy with cancer. And so again, they were randomized in niraparib versus placebo. The intent was 3 years of treatment if needed, and they incorporated this prospective change of dosing based on body weight and hematologic parameter of platelet. This trial had 2 primary endpoints, and they were done hierarchically so that if one was positive, then the second endpoint would be tested. So homologous recombination deficient, not patients. The patients aren't deficient, the tumors are. But in homologous recombination deficient tumors, which included BRCA and non-BRCA HRD test positive patients, they had a statistical assumption of a 50% reduction. And if that was positive, then all of the analytical power was passed on to the ITT population. So here's what they saw. You can tell that this is a different prognostic group because the placebo had a progression-free survival of 10.4 months. And if we go back to the Solo 1 study, you'll see here that it was 13.8. Okay, so 13.8 versus 10.4. So you can tell prognostically in the placebo population, this is a higher risk, if you want to use that terminology, patient cohort. And again, showing about a 50 to 60% reduction in the hazard of progression or death with niraparib. Now, this also includes the HRD population only. So when they looked at the ITT population, you can see even worse hazard. The placebo now is 8.2, but still a very substantial effect of 40%. So very, very consistent results. And that gets us to the Palo 1 trial, which is really important trial because in this study, everybody is getting an active drug. So we're all very familiar with how bevacizumab got approved in ovarian cancer. Again, phase 3 studies confirmed that show that it has an impact. In this trial, we took that cohort of patients and added olaparib or placebo. So everybody got an active drug as opposed to placebo. And again, the primary endpoint of this trial was investigator-assessed PFS, and there was a step-down analytic endpoint for PFS2, which I'll share with you. So 806 patients, again, more real world. So this allowed for neoadjuvant, very kind of a similar patient population. And what we saw here is that the biomarker distribution of this patient population was very consistent with what we expected. So half of the patients had what we consider HRD test positive situation. In this particular study, the predominance was in tumor BRCA. So again, I think there may be some selection because these patients were on bevacizumab but also responded. So, but you can see a high number of patients with a HRD test positive tumor. And again, you can see that, as you well know, this was about a 40% reduction in the progression or the hazard for progression or death while they were receiving therapy. But again, I want to highlight here that this teal line represents an active control. So there's not really a placebo arm here of just observation like we saw in the other trials. So this 16.6 months in the placebo arm represents the effect of Bev, okay, which is why it's not 13.8 or 10.4 like we saw in the previous other two trials. And so this was looked at in a number of subgroups, and I'm only presenting the subgroups here, and I didn't present them in the other ones because this was used for a regulatory decision. So it wasn't for statistical decision. And you'll see down here at the bottom, there are no p-values. So there's no hypothesis testing in these pre-specified subgroups because they were not analytical. But having said that, you can see that when the HRD testing was positive, that included BRCA or excluded it, that there was a significant, that there was a substantial difference in the efficacy of the combination of PARP Bev versus Bev. But in this HRD test negative or unknown, you can see the curves were very much overlapping. And the US FDA, as opposed to other parts of the world, decided to carve this population out of the approval. And so in the United States, HRD testing is now important to understanding where to use the combination. And I'll walk you through that decision process in just a second. Here's the other analytical endpoint of PALA-1. It was PFS2. And so you'll see there's a p-value here. Okay, so this represents the patients who were randomized to olaparib versus placebo while taking Bev. And then they were on that therapy until progression and then went on another line of therapy and then progressed after that therapy. So PFS2 shows that the tail of these curves, as you would expect, because it's another line of therapy, we're still splitting, demonstrating long-term efficacy of the combo. Now, because these were two drugs that each have their own toxicity, there was a lot of interest in understanding whether or not there was excessive toxicity. And what we can see here in this graphic, that there was very much anticipated toxicity, most of it low grade. The high grade events were ones that we expected to see with each of the drugs independently. And fortunately, we did not see any additive effects or synergistic effects of adverse events for the combination. So very reassuring. Now, I am going to mention a little bit about this because this high risk and low risk has been used to determine which patients are eligible for Bev. So not for the olaparib, but for the Bev. And so I thought it was important that we look at this in the PALA-1 trial, because you can see that in the high risk, which is usually the patient population that is limited to the use of bevacizumab, there was a huge difference here. And in the low risk patients where you're not supposed to use Bev because of the approval, you can see there's even a greater benefit. So this to me basically completely destroys the argument that there is this high risk and low risk subgroup within a Bev population. and it should not be used to discriminate, in my opinion. So if we put these together, basically you can see all of these long bars that are at the right-hand side represent annotated populations that would align with the role of PARP inhibitors. And so it has now become part of our decision-making process. So if you have all of the options, BEV as an option and PARP as an option in the United States, this is how the NCCN process works, decision process. So the very first decision you need to make is whether or not you're going to use BEV. That's going to define everything else. Because if you're going to use BEV, you're supposed to be using it during chemo and during maintenance. Okay, so if you are not a BEV believer, then you're going to be up here, no BEV used during primary therapy. And so you've already determined that you're going to make your decision for maintenance on the basis of a assessment for BRCA. And that can be done in the germline or somatic or both. So if the patient is wild type and you did not start BEV, but responded to treatment, then your options are to observe, which is what you would do normally if they had a complete resolution. Now, in the United States, niraparib has an ITT indication, so you could use it here. But you know, as you guys know well, that data, it is a modest effect, if anything. On the other hand, if the patient carries a mutation in BRCA and responds to treatment, then you have olaparib from SOLA-1 and niraparib from PRIMA. Now, if you're a BEV user like me, then that's going to be further annotated by the BRCA and the HRD status. So if you're a wild type patient who responds and they have a HR deficiency by testing, you can give PALA-1. And if they are proficient and you've started BEV, then you can just give BEV. That's GOG218 icon 7. Now, if you have started BEV and they carry a mutation and respond, then of course your options are to give PALA-1. And you can see in the NCCN guidelines, you can use single agent PARP in this situation. But in my opinion, you've already taken all of the risk for bevacizumab during the chemotherapy. And so to me, I tend not to do that, not to drop the BEV and just use the olaparib, but it's given as an option. So this is the guidelines all put together. You can see how the decisions are made in those boxes. And that's how we're kind of proceeding forward. Now, the field is just changing rapidly. As I mentioned, Athena had a press release on March 31st. We'll see that data at ASCO, and we'll further annotate the population. But the field is moving on to seeing if there's a role in these various subgroups that I just mentioned for the use of immunotherapy. So I'm going to go ahead and stop there, and we'll transition into the next phase, and then I'll come back and we'll talk a little bit about clinical questions. So Bob, now I'll turn it back to you.
So thank you so much, Professor Coleman. You know, it's such an explicit presentation as always. We can have a questions, I think, in the panel, but moving forward, it's the next topic is quite interesting. This is HRD test concurrence to show the utility of Indian HRD test, Amodex versus Myriad Genetics. And it's a pleasure to welcome Tam Bulun, Field Application Manager from Apex, Singapore.
All right, so thank you, Terry. So can I double check? So sorry, I can't share my screens here. So can you pass the horse right?
Sure. So Aru, can you allow, yes, please, over to you. Over to you, Tam. Yeah, wonderful.
All right, so it's my pleasure to meet all of you online here. So good morning, good afternoon, good evening to all the doctors, scientists, boys and girls. My name is Waylon. I'm the Field Application Manager for AmoDX in Apex. So today I will be the presenter for AmoDX HRD Focus Panel clinical data. So let me stop my video and move on. So right before any slide, this will be the disclaimer. So all the content, figure, chart, informations are mainly for general information purposes. So we do not have any responsibility for accuracy of the information in the slide deck. All right, so that will be the content I'm going to discuss. So I'm going to cover the introduction, AmoDX panel to all of you. And then secondly, we have a concordance data in ASCO 2021. And last but not least, that will be the efficacy data for PARP inhibitor related therapy. All right, so let's start with the introductions. So for those who do not know what is AmoyDX? So we are the company founded in 2008 and R&D based RVD product company. So in general, we provide 600,000 clinical diagnostic oncology tests per year. And then we are the IPO in Shenzhen Stock Exchange and approximately around $3 billion in the market. All right, so before we dive into this HRD focus panel, I would like to share some news for NGS portfolio. So I have this divide into different functionality. Down here, we have target therapy. It consists of essential panel, classic, comprehensive. For immunotherapy purposes panel, we have master. And last but not least, today we are going to focus on HRD focus panel. And in the subset, we can see that we have HRR and BRCA1 and 2. All right, so let's get started with the concordance study in ASCO 2021. So for those who do not know ASCO, this will be the very promising society organization for gynecological oncology. So Wilco will be one of the publisher published this paper for this topic, identify homologous recombination deficiency in ovarian cancer in 2021. So majority the experiment is carried out in Germany, Munich, and sponsored by AstraZeneca. All right, so in order to understand the concordance study for this HRD focus panel, we need to know the study design, right? So the sample were collected from those ovarian cancer. So we have a different subset. We have non-BRCA platinum sensitive HGS, as well as the endometrial ovarian cancer. So for this sample, after we collect after collections, so we will assess the HRD genomic instability by 3 panels. So down here, we have 3 panels here. First, we'll be using AmoyDX HRD focus panel. Secondly, mirrored my choice CDX. And last but not least, that would be the foundation CDX. In order to understand every single panel, so we need to understand the algorithm, how they can detect this HRD, and what is the algorithm behind every single panel. So for AmoyDX HRD focus panel, we have 2 factors. So these are very crucial factors for HRD calling. First will be the BRCA. So we do have a coverage for the entire whole coding region, BRCA1 and 2. So that will be the SNP and indel. Secondly, we have the GSS scoring. So this will be carried out by the 24,000 SNP in the entire genome. So this will be the algorithm, how we can identify the HRD status by utilizing these 2 factors. And coming across to Foundation 1 CDX, they are utilizing this LOH by determining through the SNP sequencing. And last but not least, for mirrored my choice, they have 3 factors here behind the algorithm. First will be allelic specific copy number, telomerase allelic imbalance, and last but not least, that will be last scale state in transitions. All right, coming into how is the tumor HRD positive determinations, right? So for AmoyDX, we have set by default the GSS score maybe equal and more than 50, and together with the BRCA, and every single panel they do have by default setting. So we can refer to the second row here, and 3 of them are CIVD marked, and Foundation 1 and mirrored my choice is US FDA approved. All right, so this will be the concordance study carried out by Wilco. So in the subset, in this analytical concordance, we have 2 subsets. First will be the comparison between the mirrored my choice and Foundation 1. And secondly, we have a subset for AmoyDX HRD focus panel as compared with mirrored my choice CDX. So in summary, what we can see on the right side on the top right, so as comparison with mirrored my choice CDX result, AmoyDX HRD focus panel can achieve approximately around 82% concordance with mirror my choice, while Foundation 1 CDX can achieve around 77. So for this slide, what is the summary? So in summary, AmoyDX, although we are not FDA approved, but is highly comparable to Foundation 1 CDX and mirror my choice CDX in HRD genomic instability assessment. All right, so into the last topic I'm going to cover in this short presentation, that will be the efficacy data for PARP inhibitor related therapy. So this will be the study designed in Shun Hospital in China. So for those ovarian cancer screen patients that receive a PARP inhibitor or olaparib, so we decide we have two subsets of selections. First will be the first-line maintenance therapy. Secondly, that will be platinum-sensitive relapse maintenance therapy. So this will be the selection for the study. And then so after we have this subset, we have the scientists collected all the FFP and undergo the extraction for the DNA and runs together with HRD focus panel. So in summary, we have the correlations analysis between the HRD status together with the olaparib efficiency. So at the right or left bottom, that would be a definition how we call a HRD positive in a patient by using a HRD focus panel. So in general, tumor HRD positive was defined by this score, GSS score more than or equal to 50, together with the BRCA mutations. So positive or negative. So this will be the definition. You can refer to the slide. All right, so into this PFS. So this will be the PFS we got from this study according to the tumor GSS by utilizing this our panel, HRD focus panel. On the left side, what you can see here, the first-line maintenance patients, for those GSS positive patients, you can see there is a dramatically prolonged for the median PFS, and that is a 85% hazard ratio reductions as compared to those GSS negative patients. It only has 70 months in the median PFS. Into the right side, we have the whole populations. If you do not know the whole population definition, that would be the first-line maintenance therapy plus the PSR relapse maintenance therapy patients. Surprisingly, for those GSS positive patients, out of the 37 sample, we can see that they can prolong up to 40 months in the median PFS, and the hazard ratio that is about 75% reduction in the hazard as compared to the GSS negative patients. All right, so this will be my last slide. I'm going to share with you what is the benefit with AmoyDx HRD focus panel. So first, HRD focus panel is decentralized assay with CE-IVD marking. So we provide a very accurate, precise evaluation for HRD status by utilizing this algorithm. As I mentioned just now, BRCA1 and 2, we do have the SNP index coverage for the entire coding region. Secondly, that will be the GSS score. So this will be this can be assessed by the 24,000 SNPs across the entire genome by us. And then the technology is pretty much easier, simplest. How we say so, because we are using one tube workflow from the library preparation. It takes about 5 hours. Hands-on will be about 1 hour. Total turnaround time is pretty much less than a week, sample to report. And last but not least, we are highly comparable to FDA approved assay in assessing HRD genome instability in ovarian cancer. All right, so thank you very much. This is pretty much 10 minutes short presentations. So I will pass the ball to the moderator, and you can keep your question until the last sessions. Thank you.
So thank you so very much. Hello, thank you so very much for this wonderful presentation. Now I think we need to move, and we move forward for the next presentation. This is Indian HRD testing experience, and it's a pleasure to welcome Dr. Vamshi Veer Chinani, Chief Scientific Officer from Strand Life Sciences, Bengaluru. Can you hear us, sir? Hello, Dr. Vamshi, can you hear us?
Hi, can you hear me?
Yes, now we can hear you, sir. Yes, over to you. Yeah.
All right. Are my slides visible?
Absolutely, sir. Slides visible, you're audible. Over to you, sir.
Okay. Thank you for inviting me to speak to this audience. I'll take you through the details of the Strand HRD test. The previous speakers must have covered the difference between HRR and HRD, so I won't go through those details again. But to very briefly summarize, in HRR, we are mainly looking for mutations in the genes that we believe to be part of the HRD pathway. Whereas in HRD, we are looking for what is the effect that we see on the genome if there is homologous recombination deficiency. So we're trying to identify patterns that indicate that there is that deficiency. And there are different metrics that people use to measure this instability. Over the last 10 years, people have focused on loss of heterozygosity, large-scale transition, and telomere allele imbalance, and scores which combine all of these metrics. And as a simple pictorial representation, loss of heterozygosity occurs when instead of having two alleles, you only have one of the alleles. Telomere allele imbalance is when the ends of the chromosomes are not balanced. And large-scale transitions are when you have copy number changes spread all across the genome. And we are looking for patterns of these three types of instability all across the genome and trying to compute a score. That is what almost every single HRD assay does. Now, as the previous speaker mentioned, the MOIDX assay, they measure 24,000 locations across the entire genome. And since we're talking about a molecular test, I just wanted to show you what does the genomic measurement really look like. So at every location of those 24,000 locations that are distributed across all of the chromosomes, what we're trying to ascertain is how many copies, what are the total number of copies of the genome that are present at that location, and that is there in the bottom chart. Wherever it is below the 1.0 location means there is some deletions that are happening, and wherever there are spikes in this bottom plot means that there are some amplifications happening. So the bottom plot is trying to give you for each of those 24,000 locations, what are the total number of genome copies available at that location, whereas the top plot is trying to indicate are the two copies of the chromosomes balanced at a particular location or not. So if you have a signal around the 0.5 mark, it means that there is both the copies are in equal numbers. And if there is a deviation from the 0.5 mark, it means there is an imbalance in the number of copies of A and B, and that could indicate a loss of heterozygosity. So this is the kind of measurement that is carried out across the entire genome. And from these raw measurements, we infer the segments of the genome that are present in the underlying tumor sample. So the segments are indicating, do you have balanced copies of both the chromosomes? Do you have a loss of one of them? Here, for instance, you can see the entire chromosome 4 has been lost, or do you have an amplification? These kind of segmental patterns are determined. And these segmental patterns are then summarized into an instability score. And you can see intuitively that for the sample on the left, there are very few deviations from the center line, which means the genomic instability is low. Whereas for the sample on the right, you can see that almost the entire genome, there are some aberrations or the other that you can see, which means that the genomic instability is high. So when we started using this test, the ESGO results had not yet been published. So we did extensive validation by also running whole genome sequencing of close to 25 samples and running research pipelines which compute the genomic instability score and comparing the results of the test that we eventually launched based on the MOIDX kit versus the research pipelines. So you can see at the top, you have one of the samples, the results of sampling 24,000 locations across the genome. And at the bottom, you have the same sample, but we have taken through a whole genome sequencing and a research pipeline, which computes similar metrics. And you can see that the pattern is more or less the same. You can see here the chromosome 1, the P arm has a variation, whereas the Q arm is balanced. Almost exactly the same results are obtained whether you do whole genome sequencing and academic pipelines or whether you use the MOIDX kit. So based on this, we had gone ahead and to summarize what happens actually in the protocol, we start off with a sample, we extract the DNA, we take it through the library preparation, then it goes to sequencing. The sequencing carries out two types of analysis. In the BRCA1 and 2 genes, it does whole gene analysis to determine what variants are present. And then it also analyzes this 24,000 locations across the entire genome to compute genomic instability. And both of those are then combined into a report in our software called Strandomics, and the report is generated. And the interpretation is straightforward. If you have a mutation or if you have the genomic scar score greater than 50, then the HRD status is positive. If neither of those conditions are met, then the HRD status is negative. This is just to give you a look of what do mutations look like and what does the genomic scar score look like. The sample at the top, you have a mutation in the BRCA1 gene, and it's occurring in 67% of the reads. And also the genomic scar score is 100, so it is a positive. But then you also have samples like the second and the third, where you don't have any mutation, but you have a very high genomic scar score. Those would also be positive. And samples for which the mutation, no mutations were detected, and the genomic scar score is below the threshold of 50, those would be HRD negative. So far, as of last week, we had processed more than 100 clinical samples obtained from that were sent by multiple doctors from across the country. So this chart is summarizing all of the data that was generated as from these 100 samples. So the chart is showing you the distribution of these samples with respect to the genomic scar score. And as the previous speaker mentioned, 50 is the cutoff. So anything that is above 50 would be considered to have high genomic instability, and anything below that has low genomic instability. We also color the BRCA positive samples with red and the BRCA negative samples in green. So you can see that most of the samples which have BRCA mutations also have a high genomic scar score. And to break it down into numbers, out of the 102 samples, 21 of them had BRCA mutations. So if you were to do a somatic BRCA test, these are the 21 samples out of 102 for which you would find the mutations and you would go in for PARP inhibitors. But because we are also calculating the genomic scar score, if you were to use only the genomic scar score, then 48 out of 102 samples have genomic scar score greater than 50. And if you were to use both the BRCA mutations and the genomic scar score, there are around 4 samples out here which have BRCA mutations but low genomic scar score. So overall, you'd end up by calling out HRD positive for 52 of the 102 samples. So to summarize, if you were to use only HRR or somatic BRCA testing, you would be able to call 21% of the samples as positive, whereas using genomic scar score in addition to BRCA mutations, that number jumps to 51%. Obviously, these are not carefully selected collection of samples. These are whatever clinical samples we happen to get in our diagnostic laboratory. So, but the numbers are more or less in line with what the earlier speakers had presented, saying roughly 50% of the samples turn out to be HRD positive, and roughly half of them will have BRCA mutations. These are broadly in line, but it's not obviously a statistically robust analysis. I just wanted to mention what the reports look like. If you have mutations and you have a high genomic scar score, then the report highlight will indicate that there is a mutation. It will indicate the genomic scar score, because some clinicians have expressed an interest in not just the status, but also knowing what that score was. And the details of the mutation would be presented in a table. And there would be a literature references if those mutations happen to be present in literature, etc. And for the other half of the samples which are HRD positive, they may not have any mutations in them, but they could still have high genomic instability, in which case, again, the genomic scar score is mentioned. And here, obviously, there will not be any mutation table mentioned. Yeah, that is the conclusion of our laboratory's experience in with Indian samples over the last few months. Thank you for your patience, and back to the organizers.
Thank you so very much, Dr. Vamshi sir, for this wonderful presentation. And now actually we move down to the last part of the session, and this is an exciting interactive case-based discussion. And it's again a pleasure to welcome Professor Robert Coleman. Hello, sir. Once again, you need to moderate the case-based discussion. We have the esteemed panelists with us. We have Dr. Rushabh Kothari from Ahmedabad, Consultant Medical Oncology at Narayan Multi-Specialty Hospital. We have Dr. Sirish Alurkar from Ahmedabad, again, Consultant Medical Oncology at Apollo CBCC Cancer Center, Ahmedabad. It's a pleasure to welcome Dr. Anand Pai from Udupi, medical oncologist from Kastuba Medical College, Manipal, Dr. Bhaskar Bhuvan from Vizag, from SCG Cancer Care, Vishakhapatnam, consultant medical oncologist again. We have Dr. Samya Panda from Bhubaneswar, consultant medical oncologist, Institute of Medical Science and some hospital, Bhubaneswar. Colonel Abhishek Pathak from Kolkata. He's again a consultant medical oncologist from Eastern Command Hospital, Kolkata. We have a pleasure to welcome Dr. Vineet Talwar, Sir, Director, Department of Medical Oncology at prestigious Rajiv Gandhi Cancer Institute, Delhi. Dr. Chanchal Goswami, sir, from Kolkata, again, medical oncologist, Southeastern Railway Hospital, Kolkata. A pleasure to have Dr. Shyam Agarwal, sir, Chairman and Director, Department of Oncology at Sir Gangaram Hospital, Delhi. And of course, Dr. Shrikant Boga from Guntur, Senior Medical Oncologist, Omega Cancer Hospital, Guntur. So thank you so very much, everyone. It's a pleasure to welcome you all. A small humble request, if everyone can have their video on, please. And over to you, Professor Coleman, for your moderation.
Here we go. Let's see here. Okay, there we go. Okay, thank you. Great discussion. Great to see the companies, continuing to expand the HRD testing. The what we had thought we would do would be, I would maybe come up with to talk about 4 clinical questions that arise around the role of determining the use of testing and the interpretation of the previous report. I'll go through that relatively quickly, and then we'll get to the case, and we can talk about that. We've got about I guess about half an hour, so we'll try to get through this. So the first clinical question that arises, I think, in the primary management of ovarian cancer is, what's the case for Bev, right? So I talked about this as, in the trials that have been done, the 6 trials that have been done, Bev was used only in one of them as a control arm. And so the case for Bev really comes from, the interpretation of GOG-218 and ICON-7. So this was a trial that was placebo-controlled and had bevacizumab administered during chemotherapy or during chemotherapy and in maintenance. So you can see there's no 4th arm here, which would have been this arm here, followed by a bevacizumab maintenance. Okay, that was an arm that was initially proposed, but it was ultimately pulled out of the trial schema because it was felt to be of low value. The thought at the time, remember this is a number of years ago, more than 15 years ago, the thought was that bevacizumab would have most of its activity as a concomitant therapy. And so the analytical component of this trial is actually to compare this arm and this arm to the placebo. There was no comparison made between arms 2 and 3. And so ICON-7 was done, published around at the same time, which was a non-placebo controlled trial in a less high-risk cohort of patients. And it included patients with stage 1 disease, but again, was using bevacizumab concomitantly and as a maintenance strategy. And you can see that the difference between ICON-7 and GOG-218 was that there was no arm 2. All right, this was a primary analytical endpoint. And so, as I mentioned, both these trials were published. The hazard ratio was 0.73, which represents a 27% reduction in the risk for progression or death from the initiation of treatment. So remember, different from all of our other maintenance strategies, these 2 trials essentially are taking all patients. And you can see here, it's important because in GOG-218, under placebo-controlled mechanism, that 8% of the patients actually progressed before they got to maintenance. Okay, so lots of people discount this trial because this hazard ratio was 0.73, but you got to remember it included every patient, including the patients that progressed during frontline therapy. And if you extend that into the 3 months post therapy in the maintenance setting for the control arm, you're talking about 15% of the patients that are essentially primary platinum refractory. So I think people lose the context of why this was such an important trial. And of course, in ICON 7, which as mentioned was a less heavily or lower prognostic cohort because it had stage 1 patients, we also saw a split in the curves with a hazard ratio that was around 0.87. Again, measured from initiation of therapy. And both of these studies had an analysis looking at overall survival, which didn't demonstrate an overall survival benefit. But this issue of high risk versus low risk basically came from a manipulation of data in the ICON 7 trial. For those of you who were around when this was actually originally presented by Tim Perrin, what they did is they took what they thought was a high prognostic cohort and did the overall survival analysis and did not see a benefit in overall survival. So they went back and they added other cohorts that they thought were high risk, including the patients who never got operated on, and then reran the analysis and found this. This is what was published. So when we applied this criteria to GOG218, we were not able to demonstrate a difference in a high or low risk cohort. But in our own evaluation of this data, if we only looked at the stage 4 patients, then we saw what appeared to be a difference in overall survival. So I'm not a big fan of this artificial separation between high and low risk cohorts, despite the fact that in some countries, you can only get Bev in quote unquote high risk patients. So it has independent treatment effect, and that's material to PALA-1. Now, the next question comes up a lot is why ITT versus HRD? So I wish I could tell you the answer to this. You remember, this is the ITT, this is the primary endpoint of the trial. If it were up to me, this would have been done and this would have been it. We wouldn't have to have a conversation about the HRD subgroup. But remember that this patient population did include a patient cohort that had HRD test negative or were unknown. It was about half of the patients. And as you break this down, you can see that there was a strong effect in the HRD test positive population, as we would expect. There was a strong signal in the patients that were BRCA wild type but were HRD test positive, as we would expect. But in the unknown and negative patients, which was half of the patients, there was what appeared to be no strong effect. So the FDA decided to take this non-analytical cohort, as you can see, there's no p-value, and carve them out of the overall population. So that's why it's the HRD population in the United States, but in Brazil and I guess in India, the ITT population is present. But obviously, the strongest effect for a role of a PARP inhibitor is going to be where there's genomic instability. Now, another question that comes up is, why can't I just get a next-gen sequencing panel and say, well, if there's mutations in the genes, we'll just use the PARP inhibitor where there's a mutation in the genes that govern homologous recombination? Well, I thought the two presentations that were made just before this one were really excellent in demonstrating how that genomic scar can be much more informative than the actual mutations. And one of the reasons this is important is that, if I mentioned this earlier, that if you look at these genes that govern homologous recombination, they do not all have synthetic lethality with a PARP inhibitor. Now, remember, the PARP is not a direct tumor target. It's promoting the opportunity for a double-strand break. Okay, and if that's happening, then you require these proteins to work. And remember, these proteins work in complexes. So if you have a mutation or methylation, for instance, in Fanconi C, is that going to really impact the proficiency of homologous recombination? Well, we did this by doing single gene knockout of 33 genes that govern this process of homologous recombination. This was done actually years ago with rucaparib, which is another PARP inhibitor. And what I'm demonstrating here is the IC50 change within the presence or absence of rucaparib when we knock out these individual genes. So let's go over here to the far left. You can see that BARD, RAD51, BRCA1, BRCA2, and PALB2 are exquisitely sensitive to PARP inhibition when these are individually mutated. So this was a cell line that only had a PALB2 mutation. This was a cell line that only had a BRCA2 mutation. This was a cell line that had only a RAD51 mutation. But then if you go over here to the other side, you can see there are all of these genes where there is no synergy with a PARP inhibitor. So this is a cell line that had, only an ATRX mutation. This is a gene that only had a Fanconi G mutation. And so this, again, it's imperfect, but it drives home the point that individual gene mutation is probably not going to be as helpful in identifying cells that are sensitive to a PARP inhibitor than this kind of genome-wide assessment, which is what you heard today. And so this was, I think, very nicely demonstrated. This was demonstrated in Ariel 3. It was also demonstrated in this recent study looking at PALA-1 data that was presented by Eric Pujada-Lorraine at SGO last year, where they looked at these various different panels by next-gen sequencing for a mutation within the HRR gene mix. So that the yes/no determination was made by mutations in these genes. And you can see that Ariel 3, NOVA, and Study 19 were these various different gene panels that were assessed, including some exploratory gene panels. And they compared this to what we already saw with the data I presented with respect to HRD. And what we found was that, again, it was not very helpful. So this is again, the breakdown of the genes. Let me get to the, here we go. This is the overlap between those genes and the mutations that we're seeing. So there's a fair amount of overlap between those two scores. But what we found was that we could not discriminate an effect of olaparib if we used the HRR mutation status as a way to find those patients. So if you look at this, this forest plot, you can see that none of the gene panels actually were very helpful. So it gets us back to that the individual genes, as with respect, except for the ones that I mentioned that show high sensitivity by single gene knockout, like BRCA1, BRCA2, PALB2, that those other panels do not help. And so the HRD scoring seems to be much better. Now, this is example, another way to look at this, and this was actually presented by him. You can see that the genomic instability scores relative to these panel mutations was very similar to that nice little graphic I showed you that we did almost 10 years ago with single gene knockouts. So in the studies, excuse me, the genomic instability score in PALA-1 relative to these individual genes are actually quite variable and would fall into the HRD test negative, despite the fact that they have a mutation in one of those genes. So I hope that's helpful in maybe helping to understand that particular point. Now, last thing I want to do is discuss really quickly is HRD and recurrent disease versus frontline. I'm a believer that if you're going to use PARP inhibitors, you should use them as early as possible. But it's important to know that these drugs work as treatment. So PARP inhibitors have been used as treatment in patients with visible cancer who had genomic annotation, both HRD test positive, as well as BRCA mutation in this third and fourth line. It's also been used as a maintenance strategy, and we demonstrated high degree of efficacy as a maintenance in that particular situation. We also know that patients who have an HRD score but are BRCA wild type and have visible cancer, that we can get an objective response. We showed that in Ariel 2 by objective response, so we can shrink tumors that are HRD test positive but BRCA wild type. And we showed that we can improve the progression-free survival. This brown curve here represents in this particular situation, the LOH high, which BRCA wild type patient population. This is the control, which would be the wild types. This would be the BRCA, and this is the HRD BRCA wild type patients in the middle. And we did this in Ariel 3 with rucaparib, where we took the patients who had an incomplete response to platinum before they went on PARP maintenance. And this is the data we presented in Lancet, basically showing that we could shrink tumors with a PARP inhibitor, even if they had, even if they were wild type for BRCA. Okay, so again, demonstrating that these drugs have efficacy as an individual treatment. And because of that, when we look at this in the recurrent setting, we know that we have activity in the recurrent setting, so it's comfortable to use it there. However, the most impact that we're going to get to a patient is going to be when we use it as early as possible. So we want to use it in the most opportune time that we can actually affect a cure. And so if I'm not a big fan of like saying, well, I'm going to wait and use it later, because what you've essentially said is that you know the patient's going to recur and you're going to use it later. So if you have a patient population for which you don't think it's going to work, that's fine. And we know we have an opportunity here. But the best benefit you see in the recurrent setting is actually the same patient population that you would see a benefit in the frontline setting. And I tend to use the most effective therapies as early as possible in the hopes that we can prevent this progression or actually cure the patient. So those are the major clinical questions. All right, I'll switch from there over to the case, and I'll just present this and then we can have some discussion. So I'll make this brief. So this is a patient, she's 63 years of age. She came in with your typical, kind of scenario. She does have a past medical history of mild hypertension. Her image, like what we found on exam, she had decreased breath sounds and fusion. She has a very large mass. It was actually ballotable so that, this mass would float back up and hit the undersurface of the abdomen. She's got disease in the upper abdomen. So a very typical patient with extensive disease. We did a scope and because that's our process here, and identified that she was not a good candidate for primary surgical cytoreduction. We took a biopsy of the omentum, which showed a high-grade mixed endometrioid serous cancer, and she was placed on neoadjuvant chemotherapy with PAC carbo and Bev, which was my practice. And during that first cycle of therapy, her germline panel basically came back with a negative BRCA1, so in the germline. So she did, though, have a dramatic response in her disease with complete resolution of her effusions, nearly all of her cancer gone. It was impressive. And she ultimately went to an interval cytoreduction, had a complete gross resection. At that time, we were able to send the tumor tissue off, and she had no genomic alteration or homologous recombination gene alteration, but she had evidence of genomic instability. In this, she had a myriad test here, a score of 52, which was positive. We gave her cycle number 4 with chemotherapy to allow for healing, and then she had bevacizumab for 5 and 6. And of course, because she was left with no residual disease after her surgery, her imaging study basically confirmed that. And the question is, what would you do next? So this is a case of patient who has an HRD. She falls right into the line of the indication for PALA1. And as I said, the options would, in my opinion, would be to add olaparib. And that's what we did. And she did quite well on that combination of therapy with relatively mild adverse events. I had one, if I remember right, I had to do one dose reduction for basically fatigue, but was able to complete out her treatment without incidence. So ovarian cancer, heterogeneous disease with an evolving landscape.
Dr. Coleman?
Yeah.
Sorry, before we move on, can we just ask the panelists their options in view of this case?
Okay.
So can we start with Dr. Shyam Agarwal, please? Sir, based on the case history that has been presented, what would have been your options?
No, I think he showed that so we are supposed to do HRD today in all our patients, who get a response to chemotherapy, and of course have either got a partial or a complete response after the surgery. So I think, and we have started doing HRD in virtually all our cases in order to decide whether this patient would be suitable for olaparib and bevacizumab. So in this patient, I think bevacizumab was being given already. So after the completion of definitive therapy in the form of chemo and surgery, so I think addition of olaparib is quite in order to my mind. So the only question is the kind of test for HRD which is available versus the approval from my choice. So that's the comment we like our discussion to take place. Dr. Coleman can help, although the slides were there which we saw, but then that is the question in our mind.
Mm-hmm. Yep.
Dr. Coleman, could you answer the query, please?
So the question was which patients to get HRD testing in?
No, the question is the methodology of testing. Should it be my choice or
Yeah.
you know, yeah.
So yeah, so we only have 2 tests in the United States that are FDA approved, although it's going to soon expand, just as you're seeing here. So we tend to send basically for everything. So we sequence these patients, we send them for germline and for the test positive cases, and we will send to Myriad or Foundation Medicine. I tend to use Myriad more right now, but there are more single point of contact, which I think is going to be really nice in the future, where you essentially send blood and tumor tissue and get everything done at one time. TMB, MSI, you know, all of the next gen sequencing and HRD test scoring. And so as that consolidates, I think that will be helpful to us. We'll also add in some of the other biomarkers like HER2 and folate receptor alpha, so that essentially as you get one test done, if you're going to do it, you basically get all the information you need for, you know, for the duration.
Yeah, my team would want to give some response over here.
May I please?
Yeah, sure.
Dr.
Chanchal,
Chandrasekhar.
Dr. Goswami has been trying to get in. Go ahead.
Thank you very much. I pretty much agree with your presentation, but the only thing many of my colleagues will also agree that we are not in a practice of using bevacizumab in neoadjuvant setting, mostly in our case scenarios. Rather, we would prefer to use paclitaxel carboplatin. We are more comfortable using bevacizumab in the adjuvant setting where primary cytoreduction has already been done, and after the first cycle is given, then we start on bevacizumab. Otherwise, I pretty much agree with you. I mean, if I would have done, I would have probably got a similar control even without bevacizumab and put the patient on olaparib maintenance. That's what my addition to the case what Dr. Coleman has presented.
Yeah, it's a good point. I think you know, we've kind of followed our own kind of GOG practice in GOG 262. We actually did a randomized trial of bevacizumab and weekly paclitaxel, and so in that study we allowed for neoadjuvant chemotherapy, which lots of patients got. So we got in the habit of using bev on cycles 1, 2, and 5, and 6. And we basically didn't use it on cycles 3 preoperatively and 4 postoperatively for those patients. It's a good point. This patient had a lot of effusions, as you saw, pretty symptomatic from them, and bevacizumab is quite effective in controlling effusion. So I felt more comfortable with this. But you're right, there's wound healing issues. And you don't want to delay the ultimate surgical opportunity. So I wouldn't argue that, you know, trying chemotherapy alone and then doing bevacizumab in cycles 5, 6 and maintenance would be just perfectly fine. And, you know, we didn't know at the time because we didn't have all of her tumor tissue back. But if we had known ahead of time that she was a HRD test positive type patient, I would have expected the same dramatic outcome with chemotherapy.
Hello.
Dr. Panda?
Yeah, it is the extension of the same question that if bevacizumab has not been used and HRD report comes positive, then whether we are legally, means we are safe to use a olaparib in that setting. We have got a HRD report that is positive and we have not used a bevacizumab. Patient is not consented for bevacizumab, or patient has got some constraints for which we have not used a bevacizumab, but HRD report is positive.
So HRD test positive and not using bevacizumab, is that what I think you said?
Yeah. Yes. Sir.
Yeah.
Yes, sir.
Yeah. So in the United States, I don't know what it is in India, but in the United States, there is no restriction on the use of a PARP maintenance in patients who are not on bev. So you can use niraparib. It has an ITT, you know, intent to treat or an all-comer label. But as far as the guidelines go, you know, if you have an HRD test positive patient, it's not hard to get it covered, a PARP inhibitor covered. And I assume that when, you know, Athena reports, we'll probably have the third of them available to us. But I think you can make a credible argument based on, you know, the PRIME and PRIMA study that a PARP in that setting is effective.
Thank you, sir.
Dr. Vineet Sir, you can go ahead, please.
Yeah.
Yeah, Professor Coleman, very nice presentation.
Thank you.
Was, just in my mind, you mentioned Ariel 2 and Ariel 3 trials. The HR cutoff in one was 12, the other one was 14. I mean, in the other trials also, Velia trial and the other trials, there was a difference in the cutoffs. So you have to depend upon the companion kits. Why is this cutoff different? Let's say, for example, in 12 and 14,
Yeah.
Ariel 2 and 3.
Right. Yeah. Actually, it's 14 and 16. Yeah, it's good. It's great that you remember that. So when the when Foundation Medicine, who was doing that assay, was in the process of trying to optimize their panel, they had initially and you saw it was really good. One of the presentations today for the HRD testing showed you what the distribution of score was across the BRCA and mutated and wild type. So if you look at the exact same data in Foundation Medicine, there was between 14 and 16, there was basically the same. They were very similar in terms of producing true positives and false positives, right? So they're right in that same ballpark. So they went with 14 for Ariel 2, and then they also reanalyzed Ariel 2 with 16. And what they found was that there was a little bit better operating performance, specificity, sensitivity, positive predictive value, negative predictive value by going to 16. So in Ariel 3, we used 16 as the cutoff, and that became their official cutoff. All of these companies that are doing HRD testing, though, in my opinion, we don't have a great methodology for choosing what's a positive and a negative. We tend to, even Myriad with their 1,000 sample, study, you use a visual kind of cutoff for where we thought we got most of the BRCA positive patients, and we were able to eliminate most of the wild type patients. But if you actually do a formal receiver operating characteristic curve analysis, the cutoff is actually closer to around 35 for the Myriad test. But it just depends on what you want to achieve. You remember, we all use CA-125 of less than 35 as positive and negative, but there are false negatives and false positives. We know that. So the same thing applies here. It's a test. It's not a direct measure, a functional measure of HRD, but it's pretty good. So, but that was the reason why those endpoints changed. And if you remember, in the Velia trial, which was using the same Myriad test, actually used 33 as its cutoff between test positive and test negative.
Dr. Pathak has a question in the chat. In case we have a case which is germline mutation negative upfront, platinum sensitive disease is there a point doing HRD testing in relapsed disease?
Yeah, it's a good question. So if you think about the distribution, if the patient has not received a PARP before, they're demonstrating that they're platinum sensitive, but they don't have a germline mutation, what you're missing are the 7% of tumor mutation positive, the 25% HRD test positive patients. That's a third of the patients in that patient population at the minimum who has likely vulnerability that would respond to a PARP. In my opinion, if they've have demonstrated objective response that's dramatic, that is your functional assay of a homologous recombination deficient state. And I would very much use it. I wouldn't, the point of testing it is if you really believe that an HRD test negative patient would better benefit from bevacizumab. Because if the option is nothing, I would use a PARP. But if the option is Bev, I would use that to maybe discriminate between using Bev as a treatment versus using PARP as a treatment.
Do you recommend that we need to re-biopsy in the relapse?
No, I don't think it's worth it. I wouldn't re-biopsy for HRD because once the scar is there, it's always there. Even in a patient who has progressed on a PARP inhibitor and you retest that patient, they still have a high genomic instability scar score. So it's not going to be helpful. But if you're doing it because you want to check their HER2 new or MSI or TMB, that's fine. But I wouldn't do it for this.
Thank you.
Can I ask a question? I'm Dr. Bhaskar. Can I ask a question to Dr.
Yeah.
Robert? Yeah. Just my question is regarding that for all these PARP inhibitors, we are discussing more in the serous carcinomas and endometrioid carcinomas. So what is your take of HRD testing in mucinous carcinoma of ovary? Is it
Zero.
justified or not? In case if HRD is positive, whether to
No.
use PARP inhibitors or not in that case?
Yeah, mucinous. I haven't seen a case that positive in mucinous cancer.
Actually, I also had the same similar situation. One mucinous case, I had BRCA positive. That's why I had a doubt whether to continue PARP inhibitor or not. That's why.
Yeah, that is really. I would almost question the diagnosis because it's so uncommon to see BRCA mutation in primary BRCA, or there's a mixed tumor. So one of the most common, I think, misclassifications for mucinous tumors is that it's actually an endometrioid cancer that has mucinous components. So that would be one thing I would just be, I would check its P53 and its HER2 status just to make sure that it was actually truly mucinous, because the mucinous tumors that we see in the ovary are almost 100% metastatic from the colon, and we almost never see this in colon cancer. So it's a good point. I'm glad that you were able to annotate that, but in general, we don't recommend it for mucinous cancers. And I think if, to be honest with you, if you have good annotation of that case, it would be worth a case report.
Dr. Coleman, Dr. Anand here. If I can ask you a question, now since we believe that we have to send HRD testing at baseline, and if the turnaround time is as less as 1 week, is there a role for neoadjuvant olaparib? I'm just curious to know that.
Yeah.
Yeah, because there's some evidence of using olaparib with platinum, and we all know that olaparib is anyway used with Bev. So is olaparib, platinum, and Bev going to be the next NACT kind of thing for HRD positive patients?
So yeah, I don't. So we've had trouble giving chemo and full dose chemo with full dose olaparib. It's just we did it in study 41. That in the recurrent platinum sensitive setting, I think 42 in recurrent platinum sensitive setting. But if you notice in that trial, we had to reduce the carbo dose to about AUC4, and we had to cut the dose in half of olaparib just to get it through. And we didn't see much of a difference between the chemo arm and the chemo olaparib arm during the time they were getting the combination. We saw the same thing with veliparib in the Velia trial. So I don't think giving it with chemo necessarily is going to be as effective, but giving it alone or in combination with non-chemotherapy, that is already on the table. We have a couple of investigator-initiated trials that are actually trying to address that question neoadjuvantly.
Dr. Coleman, this is Dr. Bhaskar. Just one more question. So in the adjuvant setting, in the platinum sensitive serous carcinoma of ovary, whether we should go with the solo one regimen or Paula one regimen, which one we have to choose? Because solo one showed PFS of around 55 months, where the combination showed 22 months. So which one we have to choose? Even though it's cross trial comparison is difficult, I know, but for general practice in the real world scenario, which one we have to choose?
So the answer to that question is whether or not you use Bev. So I don't think that there's any differential between Solo One and, which was all BRCA positive patients and compared against the placebo, and Paula One, which was, all comer population compared against Bev. So it's really, really tricky to make that decision. We did do a BRCA only cohort of Paula One, which looks to be even better than Solo One if you put the curves on top of each other, but not huge. The big benefit there is olaparib works in BRCA patients. So, but the answer to your question would have been made months ago, because you would have either started Bev or you wouldn't have. So once you were on the Bev path, then all of the molecular annotation is going to be telling you whether or not you can add olaparib or not. If you've not chosen Bev at all, then the Paula One regimen really doesn't play. So the answer is really whether or not you want to use Bev. So that's up, like I said, I'm a Bev user because I believe GMT20220407 icon 7. So when I can give it, I give it. But if you disagree or are not as impressed with the Bev data, then you're going to make that decision well before you're ever going to have to decide a PALA-1 regimen, because those patients wouldn't be eligible if you didn't start the BEV.
Okay, thank you.
Mhm.
Dr. Coleman, we have 2 questions in the chat. If you could please answer those.
Okay, is the response rates the same with p53 positive and BRCA positive tumors with olaparib? Well, they're basically overlapping, because almost all ovarian cancer that's high-grade serous is going to be p53 mutant. So there really isn't. In fact, if they're not p53 mutant, the tumors are not, then I would consider them probably low-grade cancers. And we do see some efficacy in olaparib with olaparib or PARP in low-grade, but it's not related to p53 status per se. It's the you know, again, the functional components of homologous recombination. And then the second question is about prostate and breast. They use a HRD. Right, I agree. And not only that, even in endometrial cancer, which I'll add is another one, we don't really have a great discriminator. In fact, we published on this that we can't find a really good discriminator of HRD test positive versus test negative cases. So those as it relates to the individual cancer, gene alterations that are defined by genomic instability are going to be very context dependent. And that's why, you know, HRR is being used in some of those tumors as opposed to HRD scoring. So it's going to be very context dependent.
Professor Coleman, can I ask one question? We are talking about HRD. I'm Vineet Talwar here. What about HRP? According to PRIMA, you can treat HRP with PARP. But can we sift out a subset where in HRP, which you won't like to treat? If at all.
So I think you cut out with the question, so I couldn't quite follow. So the HR.
Sir, HRP, would you like to treat or would you leave alone?
So for HRP cases, I tend to, so for me, the question is whether or not this is a BEV use case or not. So like I said, in a recurrent situation, if they're HRP or in the frontline situation, if I know I'm going to use BEV and I now find out that their testing is negative, I will continue the BEV because I believe that BEV is an effective control.
So like the PRIMA trial, you have the HRP. So in that they treated those patients. This was the non-BEV arm. So would you treat in a clinical practice where the benefit is slim?
Again, I don't think there's a strong effect of PARP in an HRP case, but again, the HRP is determined by a binary point in the sand, right? Or line in the sand. You know, it's less than 42 or greater than 42. As I said, if I had a score that was 41, I would absolutely use a PARP inhibitor there, even though it's test quote negative. So we've asked Myriad to provide the score itself, and I'm glad to see that the other companies here that have been presenting are also doing that, because it gives you some allowance to make a judgment as to whether or not you believe that patient actually that tumor actually truly has intact homologous recombination. I do not believe that PARP inhibitors work in PARP. Excuse me. I do not believe that PARP inhibitors work in HR proficient tumors. What we don't have is a functional assay that says that the tumor with a high or low score actually has functional HR compliance.
There is another question from Dr. Alurkar in the chat. In your case, can we use BEV first as maintenance for 15 months, followed by olaparib, or they should be used together?
Yeah, they should be used together because we don't have any evidence of this situation of using them sequentially. And the benefit is in my opinion, if you look at those survival curves, the benefit that you're going to get out of the regimens, whether it's a single agent or the combination, the biggest bang for your benefit is going to be in the first year and a half. After that time point, the event rates between the two arms are the same.
Dr. Coleman, if I can ask another question. When patients progress on olaparib, what kind of test would you suggest? We have done HRD at baseline. What next to do?
Yeah, we really don't have a good answer for that because we don't have a functional assay. but if they progress on a PARP, I generally won't treat again with a PARP. If they had previously been exposed to a PARP, then those patients may be reasonable candidates to retreat if they have demonstrated, a kind of a functional result of HR deficiency. And that would be, in my opinion, a strong response to platinum. So the AREO trial, which was trying to answer this question, was mostly in the recurrent setting for, for third line, in a third line maintenance kind of strategy. So we don't really have great data on that, but if you have access to testing and you find that there's a reversion mutation that has occurred, those tumors will not respond to a PARP inhibitor.
Thanks, Dr. Coleman. Do we have Dr. Rishabh Kothari? Dr. Rishabh, would you want to give your comments or ask any questions to Dr. Coleman based on the case presented? Do we have Dr. Rishabh Kothari? Okay, sorry. So just one last question from Dr. Acha, this is done. Can we re-challenge with olaparib in third or recurrence who received maintenance initially?
Yeah, so that question we tried to answer that question with the AREO trial but there were so few patients that actually fit that criteria, with frontline treatment. So we don't really know yet the answer to that. In all of the approvals that we have in the United States, they all have to be PARP non-previously treated. But I do believe there's probably a cohort of patients who have been treated with a PARP inhibitor who did not progress, who demonstrate a response to platinum again, who would be probably good candidates to consider it again if you could get it paid for.
Thank you. Thank you so much, Dr. Coleman. And before we end, I would want to give MoiDX team a chance to give some last comments on the robustness of their test compared to the Myriad, because this is one question that a lot of clinicians have in their mind.
Okay, that is a very good question. So as I mentioned just now, we are highly comparable with this FDA approved panel, so such as a Mirror My Choice. So we are only CIVD, but concordance data show that we are up to 82% concordance with Mirror My Choice. And the turnaround time as compared with Mirror My Choice, I think we have the benefit. So we only need about 1 week from sample to report. So that is a benefit, you can think about it. So yeah.
Sure, thank you. And with this, I would want to hand it over back to the organizers, Mr. Mathur.
Okay, wonderful. I think thank you so very much to everyone. A great discussion. Thank you, Professor Coleman, for your time and your great insight. We would like to profusely thank you for your presentations. Thanks, Tan from Singapore. Thanks, Dr. Vamshi, for taking us through the Indian HRD testing experience. But nevertheless, thanks to the esteemed panelists. One and all, thank you, Dr. Rishabh, Dr. Shirish sir, Dr. Anand Pai, Dr. Bhaskar Bhuvan, Dr. Soumya, Colonel Abhishek. Thank you, Dr. Vineet sir. Thank you, Dr. Chanchal Goswami sir. Thank you, Dr. Shyam Agrawal and Dr. Shrikant Boga. So thank you so very much for such a wonderful discussions. Looking forward for many more. Till then, thank you. Stay safe. And from all of us from the organizing team from Bhavna Aru, have a great evening. Good night to everyone. Thank you.
Thank you.
Good day.
Bye-bye.
Thank
Have a
you.
great day.
Thank you.
Bye-bye.
Support team, we can close the meeting.